This short video will show you how to design a plate cam with a translating follower. We're going to follow the written tutorial that's in the Cam Designer SE Help. Open Cam Designer either by double-clicking on the icon or find it in your applications on your computer. And double-click that and you'll get the About box. Click OK here and then find your user profile that you want and click OK. And Cam Designer main screen will open. Now we're going to open the help file, and that can either be done by clicking on the help that you see in the menu there or simply hitting the F1 key on your computer. Once you've opened that, then go to the tutorials and click on the plate cam translating follower. This is the tutorial we're going to follow in this video. The problem is a simple one. We have a translating roller follower that's going to be operating with a plate non-groove cam. Plate cam sometimes is called a disc cam. And the cam is to have the follower rise 1 inch in 90 degrees of cam rotation, dwell for 90 degrees, fall back to the starting point for over 90 degrees of cam rotation, and finally to dwell for 90 degrees to complete the cam. It's probably not necessary with such a simple cam, but there's an Excel spreadsheet that's available in the help docs on your computer that will look like what you see in the help file here. And the spreadsheet is like this. First of all, we can go through and we can just go down and highlight all of those and wipe them out, and the chart will look like that. Okay, with what we're doing here is we're going to start at 0 for the cam position, and the follower displacement, of course, will be 0 there. And then we can go 90 there, and the follower displacement then will be 1 inch. And when you do that, you'll see a line is drawn. And then we're going to go to 180, and the cam position, or follower position I should say, is still going to be 1 inch there. And then at 270, we're going to fall back to 0. And at 360, we're going to stay at 0. And that's a timing chart. In the Cam Designer main menu or main window, you can open Kinematics by either clicking on the Kinematics button or clicking on Kinematics in the menu. And once you do that, the Kinematics form will be opened, and you'll notice in the cam list it'll be Cam 1. This is a generic name for the cam. There are some things that we need to decide before we enter any of the segment data. First of all, the cam type must be decided. In our case, it's going to be circular. The follower type also must be decided, and in our case, it's going to be translating. Now, the roller part will be decided when we come to the geometry input. The other two items here, default units and starting cam angle or kinematic starting angle, can be changed at any time. Cams are designed in segments. Each of the segments will perform a certain operation on the follower. In our case, if we look at the spreadsheet, we can see that in the first segment, we're forcing the follower to move away from the center of the cam. We call that a rise. The second segment is to allow that follower to stay at that position, and that's what we call a dwell. Third is to allow the follower to fall back to the starting point That's what we call a fall. And then finally a dwell, which allows the follower to stay at that position for the ending of the cycle. In the kinematics form, under cam information, there's a drop down under profile that has a list of the kinematic profiles that are available in Cam Designer. Also in the Cam Designer help, if you go up to kinematic profile properties and open that up, you can see for each one of those profiles that are in the Cam Designer list there's a sheet that tells about that particular profile and gives you some properties for that. For each one of those, you'll see there's a graph and there's properties that tell you how to use those in synthesizing a motion that you want for the follower. Now to enter the data for the profiles, the first segment that we have from the tutorial is going to be cycloidal. So select that from the drop down. Then in segment amount, we're going to put in 90 degrees. And then in the segment increment, you can have that as small as you want. It's going to be a function of how much memory you have in your computer. The other thing is if you enter a very, very small amount, it's going to take longer for the computation to take place. So in this case, we're just going to enter a 1. Notice that degrees have been added to those because we selected circular type for the cam. Now the next thing we want to do is over here to the right, we have the follower direction is going to be a rise, and then the follower displacement is 1. The last thing we have to enter is the final velocity, which in our case is going to be 0. Once we hit the new button, we could enter or just click on the save button, and if we do, that segment now is entered into the all segments data table. And if you go down here and click on segment data and graph, you'll see that segment is there with the graph for that segment below that. There's a bit of a caution I need to tell you about here. We clicked on save, the save button here in Kinematics. Notice that in the information for the cam, cycloidal, all that is still there. If we enter information now, at this point, if we would say select a different profile and put in dwell, which is the next segment, what it's going to do is going to edit this segment that we've already entered. So the way to enter a new segment is to click the new button. Now we'll just go ahead and finish up the other segments of this cam. The next segment is dwell. You can find it there. And then enter 90 for that segment. Click the new button. The next segment in the tutorial is going to be again cycloidal. We're going to enter 90 degrees for that, and we'll stick with the 1 for the increment. And now over here, it's going to be a fall. The thing we can do is to click that arrow, and that's going to give us the highest amount of rise we have for a translating follower. Enter 0 for the final velocity. Click the new button. And then finally the last segment is going to be dwell for 90 degrees. To finish this tutorial, let's look at some of the output that we have available. First is the segment data, which we started with, and that'll just show the segment data by itself. We could have the tabular data, which will just be a table of calculated, computed values for this, the kinematics for this cam. We could have just the graphic output. We can have the tabular and graph together, or we could have what we had there was the segment data and graph. If you look at the tabular and graph, there's some things we can do here. First of all, we can select whatever profile or whatever output we want. And in this case, let's just select velocity and click maximum. And it'll show where that maximum velocity occurs. It will give you the cam position for that and the amount of that velocity in this table, or in this output edit box. If we then click on the track line and click on that cell, we can see where that occurs in the graph. If you notice here in the cam list, this cam is called unnamed. And also for the kin, it's called unnamed. The reason that is because we have not saved this kinematics data to the hard disk. If we go here to this icon for a disk and click Save As, Plate Cam Tutorial. When we click on Save, it says it's been saved successfully. And now notice the cam name is Plate Cam Tutorial, which is the name of the kinematics. This completes the entry of the kinematics for this cam. In a separate video, we're going to be doing the entry of the geometry and some explanation about the geometry for this cam. Thanks for watching. For more information, visit www.delta-eng.com.